Hello everyone, welcome back. In this video, you will be learning the function and uses of a simple machine. Then you will be also learning some technical terms related to a simple machine, and finally you will be learning about mechanical advantage, velocity ratio and efficiency of a simple machine. So let's start. First, function and uses of a simple machine. So first function it is in lifting a heavy load by applying the less effort, that is as a force multiplier. For example, we know that a person cannot lift a car by just using his hands, but using a jack it becomes easier to lift a heavy car. Thus, here the force applied, that is the effort force, gets multiplied using a jack in order to lift the car with very less effort. Thus, here the jack acts as a simple machine used for force multiplier. Second function, in changing the point of application of effort to a convenient point. For example, in a bicycle, we apply effort on the pedal. This pedal is connected to the back wheel of the bicycle with a chain. When the force is applied to the pedal by the rider, it rotates the back wheel of the cycle and helps to ride the cycle. So we apply effort to a convenient point, that is pedal instead of front wheel or the back wheel directly. Similarly, this is a hand rider. A hand rider can be rotated easily when its handle is at the rim of the grinder. Therefore, we are applying effort to the rim of the grinder, which makes it easy to rotate the hand grinder. Now, next function is in changing the direction of effort to a convenient direction. For example, a pulley. Using a pulley, we can change the direction of application of force. Here, it would have been difficult to pull the bucket full of water from well directly against the gravitational force. But using a pulley, we are applying force in the direction of gravity, which makes it easier to pull the bucket. Thus, here we are applying the direction of effort in the direction of gravity in order to pull the bucket easily. Next function is for obtaining a gain in speed. Example, a knife. A knife has a sharp edge which allows to cut vegetables easily at a greater speed. So, a sharp edge or wedges are machines which is used to gain speed in the work. So, these were the four functions and uses of a simple machine. Now, next we will be learning technical terms related to a simple machine. Here you can see a simple machine. This is a lever. A lever is a simple machine consisting of a beam or rigid rod pivoted at a fixed hinge or fulcrum. A lever is a rigid body capable of rotating on a point on itself. On the basis of the location of fulcrum, load and effort, the lever is divided into three different types, that is class 1, class 2 and class 3. Now let's see what is technical terms related to a machine. First, load. The resistive or opposing force to be overcome by a machine is called the load. It is represented by letter capital L. Now second, effort. The effort applied, the force applied on the machine to overcome the load is called the effort. Now in this GIF, the load is the 1 kg, 1 ton weight which is to be pulled or lifted by the man, and effort is the force applied by the man on the other side of the rod, or you can say other side of the plank. Third is mechanical advantage. The ratio of the load to the effort is called the mechanical advantage. So I can say mechanical advantage is equals to load upon effort. If the mechanical advantage is greater than 1, the machine acts as a force multiplier. That is, using just applying less effort, I can lift or I can do more work. More heavy objects can be lifted. Second, if the mechanical advantage is less than 1, the machine gives the gain in speed. And third, if the mechanical advantage is equal to 1, the machine is used to change the direction of effort, as there is no gain in force and there is no gain in the speed. Now next, effort point and load point. So here you can see the point at which the energy is supplied to a machine by applying the effort is called the effort point, and the point at which where the energy is obtained by overcoming the load is called the load point. So here in opening the lid of the tin, effort, I am applying the force at the handle of the screwdriver. Therefore, effort point is at the handle of that screwdriver, whereas the load is at the point where the point at the lid where force is applied. So this point is the load point. Now work input. The work done on the machine by the effort is called the work input. Work output. The work done on the machine on load is the work output. Now what is efficiency of a machine? Efficiency of a machine is the ratio of work done on load by the machine to the work done on the machine by the effort. That is, I can say efficiency is equals to work output divided by work input multiplied by 100%. We usually denote efficiency in terms of percentage, therefore we multiply it by 100 to denote it in the percentage form. Velocity ratio. The ratio of velocity of effort to the velocity of load is called the velocity ratio of the machine. So velocity ratio is equals to velocity of effort divided by velocity of load, which is equals to dE upon dL, where dE is the displacement of the effort point due to the application of the effort force, whereas dL is the displacement of the load point due to the effort force which overcomes the load force. I hope you understood. So here, if dL is greater than dE, that is displacement of load is greater than displacement of effort, then such machine will have velocity ratio less than 1 and it will give gain in speed. If the velocity ratio of machine is greater than 1, then the machine will act as a force multiplier. If the velocity ratio of a machine is 1, then such machine generally changes the direction of effort. Now, principle of a machine. For an ideal machine, for a machine where there is no loss due to friction, due to weight of that moving parts or weight of any of the parts of that machine, such machines are called ideal machine. But for an ideal machine, output energy is equals to input energy. Now input energy is always force multiplied by displacement. Energy is equals to work done at the effort point, that is equals to force, that is work done at the effort point is effort. So that is E effort multiplied by displacement of the point of application of the effort. Similarly, output energy is work obtained at the load point. So which will be equals to load multiplied by displacement of the point of application of load. Now ideal machine versus actual machine. So efficiency of an ideal machine is always 100%, but in actual machine efficiency is never 100%, it is always less than 100% because of the loss in friction and the weight of the parts of the machine. Second, its parts are weightless. In case of ideal machine, the parts are weightless, elastic and perfectly smooth. But for actual machine, its parts are never weightless, elastic, nor it is perfectly smooth. Now third point, there is no loss in energy due to friction in case of ideal machine, but in actual machine there is always loss in energy due to some friction. And last point, in ideal machine work output of such a machine is equal to the work input, but in actual machine work output is always less than work input. Okay, now next, relation between efficiency, mechanical advantage and velocity ratio of a machine. So if E is the effort to be applied to the machine to overcome a load L in time t, let the displacement of effort be dE and the displacement of load be dL. So work input will be equals to effort E multiplied by dE. Work output will be equals to load multiplied by dL. Efficiency, we know it is work output upon work input. Therefore, efficiency eta is equals to L multiplied by dL divided by E multiplied by dE. So now I know L upon E is what? Load upon effort is equals to mechanical advantage, and dE upon dL is equals to velocity ratio. So I'll substitute this values in the efficiency equation. So I'll get efficiency is equals to mechanical advantage divided by velocity ratio. I can also write mechanical advantage is equals to velocity ratio multiplied by efficiency eta. So this is the relation between mechanical advantage, velocity ratio and efficiency. So that's all for this video. Continue watching next videos for pulleys and combination of pulleys. Thank you.